What we're going to look at in TBC just now is processing a RTK basin rover survey where the base has been set on an unknown point. So a here or an autonomous position has been done for the base station. So in the single project, what we're going to do is take in the job file with the RTK data. We're going to take in the static data from that base station, and then we're going to take in the Ordnance Survey active network RINEX data and process everything and reduce everything to Ordnance Survey together. So before we start, what we'll do is we'll just open up a TBC project. We'll choose an appropriate template. So I always have a template saved with the Ordnance Survey coordinate system in it. So I'm going to choose that template. And then we can start dragging in our data. So the data that we have, first of all, is the job file with the RTK data in it, and then the base station data, which is normally a T02 or a T04 file. So we just drag and drop it into Trimble Business Center. And then you'll quite often get this in Trimble Business Center, and it just notices a very, very slight difference in the definition of Ordnance Survey. If we're happy what's done in Trimble Business Center, the way it's been set up in our template, then we just choose keep the existing project definition and click OK. And this is just identifying the static data. We don't want to send it to RTX, post-processing. We can just check that everything's filled in correctly for the antenna height and the receiver model, and then we can just click OK. So when we're reviewing the data, I often like to use the Project Explorer. So on the left-hand side, you can open up the Project Explorer, you can open up the view filter, and these are just placed on top of each other on the left-hand side. So we see the options from the home menu to open them up. And then I always just leave them open, and I'm constantly flicking between View Filter Manager and Project Explorer. So when we have the data in Trimble Business Center, then in the Project Explorer, we can look at the imported files, and we can see that we have the job file and the T02 file. I like to look at the job file in the imported files section of the Project Explorer because it shows you the chronological order in the survey. And we can basically see that these are all RTK vectors. And if I select them here, then we're seeing them selected in the map screen. And likewise, if we select them in the map screen, we'll see them selected in the Project Explorer. So we see it here. Now in Trimble Business Center, we see our RTK data all as vectors. So essentially what's calculated by the receiver and stored in the controller is a dx, dy, dz vector. So that the base station position moves, then because we just have a relative position stored, then the rover position will also move. So when we click on these, what we actually see is coordinates, but we actually see the observed data is actually this dx, dy, dz vector. That's what's actually being stored. What we'll also see if we click on the vector is the precisions of that point and how many satellites were being tracked, how long the observation was recorded. So this was obviously done as a rapid point because it's done as a 1 second. Number of epochs here is 1 second. RTCM age, this is telling us how long the delay is between the base station producing a correction and the rover recording it. So normally we'd expect this between 1 and 2 seconds. So what I also would like to look at is the points. So in the points section of the Project Explorer, we can essentially see this is a point, it has a coordinate, and we always see in the field below where that coordinate's actually coming from. So we can see that this point, 15112101, has a coordinate of this easting northern level. Where's that coming from? Well, it's actually coming from this vector, which comes from the base station. So the base station has a coordinate, then we have a dx, dy, dz, and that's where 15112101 gets its coordinate from. Now we have some other points in here that have their coordinates from somewhere else, and that is the base station. So if we look at 151121, which is the actual base station itself, it has basically got two coordinates attached to it. So whenever we see this sort of black and white propeller, it's telling us that's an attached coordinate to that point. So this coordinate for 15, 11, 21 is coming from the fact that there's a keyed in coordinate, and that is when we've done here in the field. And these basically, we have two of them because we've got one from the T02 file and one from the job file. We can just delete as long as we leave one of them. And the other thing that's very important to think about is what accuracy is this point. Trimble Business Center won't know what accuracy it is. It basically will just assume that it's a control quality point a lot of the time. We need to tell Trimble Business Center this is an unknown quality point. And what that means is it basically just moves it up or down a hierarchy. So if we move it from being a control quality point to an unknown quality point, then when we bring in the static data and calculate a vector, if one side of the vector has a control quality point and the other side is an unknown, then the vector will basically come from the control quality point to the unknown quality point, and the point, the base station position will move. So the direction of the vector will always be coming from the known to the unknown. So just to demonstrate this, what I'm going to do is I'm just going to key in a point directly on top of this, and I'll just call this old base. So I'll just go and call this old base, and I'm going to drop that directly on top of that position and choose add. Okay, so that's all I'm going to say about the RTK stuff just now. The next thing we're going to do is take in our ordnance survey data, and we've got guides and how to do this, but essentially it's straight from the Ordnance Survey website. So we can basically just drag and drop that the Rhinex data directly into Trimble Business Center. We just want to deselect the RTX option and hit OK. And then we've got all these base stations loaded in. And again, through the Project Explorer and the points section, then we can just go in and we can just go into each one. And it's very important that these are our known points. These are our control quality points. We can just go in here and we can basically flag them up as being control quality points. So in turn, there's no faster way of doing this, I'm afraid, or no, there is, but I would rather not recommend it because it depends on you always making sure that the coordinates have not changed, and strictly speaking, occasionally the coordinates for Ordnance Survey base stations might be tweaked. So once I've fixed all of those control quality points, then what we normally would want to do is just disable the baselines that are going between these known points, because we don't need to calculate those. So we just select them all, right click, and we choose disable on the baselines. Now on the View Filter Manager on the left hand side, what we can do is we use this to basically control what we're seeing at any one time. So things like layers. So as we've got our layers, we can toggle them on and off. As we've got our different types of surveyed points, we can toggle them on and off. We've also got some general settings at the bottom, and one of the useful ones is under GNSS data types to view only by enable baselines only, and it just clears up the screen nicely. So what we want to do now is, it's not strictly necessary because we do have a T02 file which has a precise ephemeris file, but it's probably good practice to just go into the survey tab, go to internet download, and even if we say we choose an ultra rapid orbit file. So this is basically a precise ephemeris file, which basically is the updated position for the satellites as they were being tracked. So we have broadcast ephemeris files, which are available real time, which is what we log in the T02 file. If I'm coming back and I'm processing the same evening, then I would use hour 00. If I'm processing the next day, then I would use hour 12. If I'm 3 days or more later, then I would use rapid orbits. But even if we use T0, the hour 001, which is available pretty much straight away, it will often help our processing. So you can see that we just select it, and then it's downloaded, and we just hit import. And then what we can do is we can just choose to go to process baselines. and it's going to process these baselines. Notice the direction. The direction is from the control quality point to the unknown. So we're basically, this is a fixed point. We're calculating a dx, dy, dz, and the base station position will be adjusted. So we're just looking to make sure these precisions are all okay, which they are, maybe a little bit higher towards the bottom, and then we hit save. And we can see that we have some red flags here. So we see we've got the baseline still, but we now have a post-process vector. So basically, instead of a real-time vector, so what we got in the RTK data, we got a dx, dy, dz from the base station to the rover real time. This is basically a post-process, so it's available afterwards, going from these base stations to our base station. So we now have, if we click on these, we can see how many satellites were being tracked and all the rest of it. So if we just zoom in, we have these red flags. And you'll notice that, as we expect, we've seen that the base station has moved from the old base position to the new base position. So this has been superseded, and that's all governed by the direction of the vector. So which end of the vector is control and which end of the vector is unknown. Now, the current position for 151121, it's maybe not a particularly rigorous way that's been done, but essentially its current position, this coordinate, will be coming from the alphabetically first. So this will be RSIG. It's got a coordinate, we've got a dx, dy, dz, and that's where the base station position. So that's where the coordinate is coming from. And then all the other base station vectors, so the vectors that are coming from Fort Augustus, Colin, Lochgilphead, Oban, basically are just also calculated, but they're there for a comparison. And the way that we can use that is we just right click. So we select the actual point, we right click. So what's going on there? Select the point. So that point there, right click. We just close all there just now. There we go. And we choose the point derivation report. And the point derivation report basically shows us this in this part. It says the RTK, it's actually a post-process vector, but the post-process vector RTK is essentially held as fixed. So basically it's 0, 0, 0, that's held to be true. So essentially that's where the coordinate's coming from. And when we compare RSIG to it, because that's where the coordinate's coming from, then they will all be 0. And then the vector from Oban is 5 millimeters different in easting, 8 millimeters in northing, 10 millimeters different altogether in that vector, and then 30 mil in height. And we're just looking for the comparisons here, and we can see that the one right down the bottom, which sometimes scares people, is saying that we've got this 243 1 meter, 1.522 meters, and then 2.392 in height. This is basically the original coordinate for that base station. So this is how far the base station's moved from the here position that we've put in the field. So we see that there probably is an outlier here, and that's that one Lochgilphead, 63 mil different, and possibly I would be inclined to say maybe we should just disable that, and it's about the furthest away point. So what we can do is we can just select the baseline, and we can just choose disable baselines, and when we disable a baseline, the vector that's been calculated from that baseline is now removed. So if I was to basically select this point again and another point derivation report, then we can see that everything basically agrees within about 30 mil in the height, and it's always the height that will see the worst values. So what we can do now is we can basically just choose to do a network adjustment, whereby instead of just using only the data from RSIG, we're going to use basically a least squares adjustment from all the baselines from what we have here. So we're just going to adjust network. We're going to use this option to constrain all of these base stations in 2D in height, and then we're just going to choose adjust. A lot of the time with post-process vector data, you won't pass straight away. Here we do pass straight away, and it's all about predicting the errors in the data correctly, and quite often you'll slightly under predict them. So often what you'd see is maybe this is sitting about 1.4 or maybe even as high as 2. And what you'd have to do is basically just hit the multiplication there. And essentially what we're doing is re-estimating the errors that are in the actual post-process vectors. And we'll just run the adjustment again. And then what we can see here is passed. What's very good to do here is we can actually click on each one of these vectors. And now what we're seeing is how does the final coordinate for the base station in the middle compare to the observation from RSIG? And you can see here that it compares within 15 mil. And we can move around and choose each one of these. That one's 4 mil, that one's the same, and that one's the same. So we can see it's looking pretty good. And if we actually go in, so we're just using the results tab here and selecting these vectors. If we actually select the point, the base station point, we'll actually see the estimated errors for that actual base station. So this is our confidence in our result. So that all looks very, very good. So we can just hit OK, and we now have the base station coordinate. If I select that point and rerun the point derivation report, then we're seeing that we now have this adjusted value for the easting northing levels, so nothing will be perfect against it. And then we compare RSIG. Essentially what we're seeing is we're seeing these same residuals that we saw on the last page, and we're seeing them demonstrated on this table here. So this looks like we're ready to basically carry on and actually process our topo survey. So essentially what we now have is everything is now in true ordnance survey grid, and we can now apply our feature coding. So we'll stop there just now.